Hello everyone, we are 100% engineer. My name is Jing Wen.
I'm Jeremiah.
Ivan.
This project is our take on a typical maze game, but integrates mechatronics. The goal of this game is to navigate a ball through a maze, avoiding pitfalls and attempting to reach the end of the maze. An Arduino Uno and the Feather NRF board were the microcontrollers used for this project. The maze is capable of rotational motion using two servo motors and a stepper motor that are attached to the bottom of the maze platform, and the servos are controlled by an analog joystick. One proximity sensor is used to sense when the ball falls through the holes, and another proximity sensor is used to sense when the ball goes to the end of the maze. We decided to design the 3D maze game as a mechatronic solution to solve indoor activity boredom. Our project was to follow several functional and design specifications. After sensing the ball, there would be an LED output and a sound. It would be designed like a game, so it would have 3 tries, end in a game over, and require a button press to restart. In addition, the maze itself should be lightweight so the motors are able to support the maze, the ball, and the sensor.
Our electric part, we basically have 14 electronic components for our circuit, and will be the layout for our circuit. And next, I will show the demonstration for our project.
As you can see, I'm using the joystick to control two servo motors for X and Y rotation. The main maze has holes for traps, as well as a stepper motor to raise the difficulty. We made a 20-degree incline base to allow failed ball activate the nerf ball sensors. When it fails within 3 times, nerf ball speaker will play a certain tones, and we also add 2 LED in the base to indicate player results. When the ball fell for the 3rd times, the right LED on the right corner will light up. Now, let's have a closer look at regular tone and the losing tones. We also code the bottom one as a restart key. When you win the game, the proximity sensor at the end will catch the rolling marble and send signal to light a green LED. Next, Ivan will talk about what we learned.
So what we learned and final thoughts. In this group project, we learned how to program a maze game and organize Python codes based on what we learned from ME106 class. Also, we learned how to design a maze with cardboard. If we had more to do it again, we would first test before selecting the cardboard materials and decide its size so that the maze would be lightweight for motors to support, which will save us a lot of time. For example, the first maze picture on the upper right corner is the first maze version that we made. It looks pretty easy and simple because I was afraid that the motor cannot support the maze if it's too big or heavy. After communicating with Barry and doing a test on the motor, we recreate a new maze which is more challenge and fun. If we had more time, we solving maze that knows its position and the ball for the next move, and shrink all components to one microcontroller.
Thank you everyone, that's all for us.
Thank
We're
you.
open for any questions.